Velocity time graphs and acceleration. Just as we could plot displacement versus time, we can do the same with velocity versus time. So a velocity time graph, velocity will be on the y-axis, time on the x. Notice how it's labeled, and it also has the units with it. What does the dashed blue line over here tell us? The dashed line shows the velocity over time, and that is constant. Okay, if you read it right here at t equals 0, the velocity is 6 meters per second. You read it over here at 10 seconds, it's still 6 meters per second. So what does that tell us about the acceleration? Since acceleration is the change in velocity over time, this line tells us that the acceleration is 0. There is no change in velocity. The slope of the blue dashed line is also 0. What conclusion can we now make? Just as the slope of a position versus time graph is velocity, the slope on a velocity versus time graph, or short VT graph, is the acceleration. Can you find the slope of the blue line over here, which represents the velocity of a car that starts at rest where v is equal to 0 meters per second? What does that slope represent? We put in a couple dash red lines to help you out. The slope represents the acceleration of the car. So during the interval from 0 to 5 seconds, 5 is right around here, up here, the delta v is 10 meters per second, a plus 10 meters per second, right? The final velocity is 10, the initial is 0, so 10 minus 0 is 10. The time is 5 seconds. You divide, and you get the acceleration is 2 meters per second squared. How would we show a negative acceleration? Well, hopefully we can think that it will be a negative slope. So we have our blue line over here, which does have a negative slope, so it looks like we're on the right track. And what's our change in velocity? Well, the initial is 10, the final is 4. So we have 4 minus 10, that's going to be minus 6 meters per second. Time is always going to be positive, and we go from 0 to 10. So we put the 10 seconds in here, and we get a negative 0.6 meters per second squared. And notice how the units work out, right? Meters per second divided by seconds will be meters per second squared.